Okay, I first of all want to apologize for the first video not having any noise. In my defense, I was recording it at 6:30 at night, so I was already checked out. So I apologize. So obviously, I'm going to do another one so you can actually hear what I'm saying to follow along. Okay, so this is the data that we collected for the first part, so pressure versus volume. Okay, so the first thing that we're going to have to do is convert these. So I realize that we only have, it's like what, 8 sets of data here. And you're like, well, why can't I just convert it by hand? That's fine. But when you do research, you're going to have thousands and thousands of data points that you're going to have to plot. So it's 10 times easier to do it in Excel. And this is why I'm going to show you how to do it. So the first thing I'm going to do is title this liters because this is what I'm going to put this. And I'm going to tell Google Sheets exactly what I want it to do. I'm going to say, I want this number. And since we're going to liters, we have to divide by 1,000. I want this number divided by 1,000. Okay. And then it gives me my answer, right? But instead of doing that for each column, I can just click here, hold this little box, and drag down. And it does the math for everybody in that column. Okay. So that's liters. The next thing I'm going to convert to is atmospheres. So for every 1 atmosphere, we have 101.325 kilopascals. So I'm going to say equals kilopascals divided by, because I need to get to atmospheres, 101.325. Enter. I'm going to do the same thing, right? I'm going to click here. I'm going to pull it all the way down. Okay, cool. So now I have my first graph that I can create. So how I create a graph is, what I'm going to do is I'm going to grab these 2 columns right here. Okay. And I'm going to go up to Insert, Chart. And Excel or Google Spreadsheets is very good at looking at the data that you're plotting and giving you the right graph that goes with it. Why is it not charting? Insert. Insert. Is it really going that slow? Oh my goodness. It really is going that slow. Okay, cool. So here's our graph, right? Oh my gosh, this computer is so slow. Sorry. And this is exactly what we expect to see, right? So they have an indirect relationship with each other. So as one increases, the other one decreases. And that's exactly what we see here. Okay, so the first thing I'm going to do is I'm going to retitle my graph. So I'm going to come here. And I'm going to say pressure versus volume. And it's already labeled my axes for me. Pressure is on the y-axis, liters is on the x-axis. Okay, so that's the first graph that we're going to do. Now I'm going to move this out of the way because I need to use my data here. Again, it's moving super slow. Okay, now I have to graph liters versus 1/atmospheres. So just like I did before, I'm going to come here and I'm going to create a new column, 1/atmospheres, and I'm going to say equals 1 divided by atmospheres. So let's talk about why we're doing this. We are doing this because we want to figure out what the moles are, right? So when we do this, when we do liters divided by atmospheres, you're ultimately converting it into P times V, okay? So with that being said, when I do this, you're like, well, so they're not next to each other, so how do I graph them? So what you're going to do is you're going to take the liters column and pull it down, and you're going to keep it clicked, and you're going to hold the control button and let go of your mouse, okay? Then you're going to come over here and pull it down and let go. And now both of them are highlighted. Okay. So now what you can do is insert, chart, and it gives you the other chart. Okay. But it's not scattered. So now we have to change it. So I'm going to go here to column chart, find the scatter plot, which is down here, and it fixes it for me. And we'll notice that we have no labels, so we have to do that. So we're going to go to Customize, Chart Axes and Title. Chart title is volume versus 1 over atmospheres. Nope. 1 over. There we go. Okay. 1 over atmospheres. And then my horizontal axis is the volume in milliliters. And my vertical axis is 1 over atmospheres. Okay? So we're good there. And now what we're going to do is we're going to stay on this customize, okay? And we're going to scroll down and click on series. And then I'm going to scroll down even more, and I'm going to see something that says trend line. I'm going to click on this because what this is going to do is give us a line of best fit so we can get a slope. Okay, so I'm going to do trend line. And so here's our best fit line, which looks pretty good. We got some really good data. And I'm going to go down even more. And then where it says label, it's currently saying no. I'm going to check use equation. Okay, so this is telling me, if you remember the equation for a line, it's y equals mx plus b. Okay, so this is your y-intercept, and this is your slope. Okay, so what we can conclude from this data is, if I scroll down here a little bit, so we know that PIVNER is PV equals nRT. Okay, so for this lab, we're going to use the R is equal to 0.0821, and the temperature, which I should have told you in the lab, but I didn't, was 25 degrees Celsius. But we know that we need Kelvin, so we're going to add 273. So 25 plus 273 is 298 Kelvin. Okay. Now what we just solved for with this slope of the line is basically P times V. Okay. So we can replace, we don't really care what pressure is because we're going to use the slope to help us solve. So I'm going to rearrange the equation for moles. So I'm going to say moles of air is equal to RT divided by PV. And then I'm going to solve. Okay. Whoop, sorry. So I'm going to say is equal to R, which is 0.0821 times 298 divided by PV, which is our slope, so 0.109. So based off of the information that I got, I had 224 moles of, nope, I did it backwards. I'm so sorry. I solved for the wrong thing. I was like, this is way too big of a number. So I accidentally solved backwards. So this should actually be N is equal to PV over RT. Okay, so I flip-flopped them. I'm sorry. It's been a long day. So I'm going to say is equal to our slope, which is, I already forgot it, 0.109, 0.109 divided by 0.0821 times 298, close the parentheses, equals, okay, that makes much more sense. Okay, so based off of the data that we collected, this is telling me that I had 0.00445 moles of air inside of my little syringe. And that makes sense, right? Because there wasn't a lot of space there. So we wouldn't expect to have a ton of air moles. So I hope this helps. For your next graphs, you're going to have to look back at the pre-lab to see what graphs you need to illustrate your data for pressure and temperature. Thanks, y'all.